Yeah, he's watching me slaughter his presentation. So.
We have a camera on him as he rides.
So if there are flaws, they're probably mine. On the plus side, there are some things where I was looking through and that he'd written things that aren't quite correct, and I'll have the opportunity to just point them out and fix them as we go along. So we're going to quickly go over rolling just enough to understand what goes in a block. We're going to talk about the RChain state, blessed contracts, and the block structure. And I'm going to gloss over Casper because that's the part of this presentation I understand the least about. So Rolling is a parallel programming language. There is no semicolon. There's only parallel. And if you need something to occur in sequence, you basically have to make it have a data dependency, or there's no other way to force things to be in sequence. So there's sends and receives, news, and there's some other things but these are basically what sends and receives are what matter for blockchain, because everything else gets evaluated down to sends and receives that are waiting, and that's what forms the state of the rolling or of the blockchain. So names are either quoted processes or unforgeable. That's not quite all. Names are quoted processes. There are just unforgeable processes. When you create an unforgeable name, it lives within a scope. Scopes are something you've seen in lots of other programming languages. So contract definitions create a replicated receive along with, there's a semantic difference in terms of payment, but we're going to gloss over that for this presentation. And so when a send and receive meet, it produces a COM event, and those are the things that are going to go in the transaction ledger in the blockchain. So what is the state for the RChain blockchain? The state is one giant Rolang term. That's it. So it's interesting, though. Mike and I sat down and we realized that there's a subtle distinction between, like, a lot of times in Pi calculus, you're given one giant term, and thus shall it always be, and then it reduces. And in our case, we also have an event called deployment, where you take the term and you add new things on it. And it turns out that you can't pretend that the term was always the new term, because things that reduced one way and then you add something on, well, if it were the whole term to begin with, it could have gone the other way, but that's not how we're not doing it that way. It's just you put new things on, you change the existing term as it has reduced to a new term with some additional stuff, and now that term can reduce further. But we never go back in time and try and like, oh, well, this could have matched over there. No, that leads to killing your own grandfather. So everything is one big rolling term, and that rolling term can change, and the way that it changes via deployment. And that is the only thing that, so it changes via deployment, and then after deployment, it reduces. So that's how you interact. So you deploy, S goes to S par P. You pass on basically how you're going to pay for what you're deploying. And that arrow is not the same arrow that you would, it's not a reduction relation. This is, it's one level outside of the reduction relations. You can basically deploy any valid Roland code. And we'll talk about you don't have to just deploy a contract. You could deploy things like, if you have a wallet, you could deploy a message along with its a send that includes some instructions and a signature, and then your wallet does the thing that you didn't have to deploy any new contracts. You can just deploy a send, which would act in a lot of ways like a method call in some other environment. So the blockchain runtime environment will be different from the interpreter. For instance, what does it mean to write to standard out on the blockchain? There isn't going to be a standard out. There are things like different things will be active, like the rev contract, the registry, unforgeable names are unforgeable. You can't produce. You can see what it is. You can go look at the block and you can see what the name is, but because of the way that you write roll-end code and send it to validators, there's no way to produce the unforgeable name. It's actually kind of magic. I mean, it's just straightforward how it works, but it's really kind of cool. Like, what do you mean it's unforgeable? I can look. I can see exactly what it is. Yeah, but you can't write it down.
You can't write code.
Yeah, you can't write code that contains it.
And if you could, all the other validators.
Yes, that would be something that we would consider equivocation, is if you produced if you forged an unforgeable name, then, yeah, you're not Don Quixote, you're just slashed. So, blessed contracts. Like Mike said, no one pays to run the blessed contracts. You might have to pay to interact with them, like it's listening, but no one pays for their storage. So they perform certain system critical tasks. The rev mint will be a blessed contract. The registration contract and the proof of stake contract, and possibly others. So blessed also means that certain parts of the system will look at the contents of that contract and make decisions on it. So the proof of stake contract is the blockchain visible part of the proof of stake algorithm. It's the part that has to come to consensus. It's the mushroom part of mushrooms grow underground and then they like pop up and you can see only a part of. Anyway. So the rev contract, we should have a session on in the breakouts about how mints are different, how they behave, things like spawning purses and absorbing purses, and like, because that's kind of it's likely foreign to people that have seen like Bitcoin-based triple bookkeeping, or even like a ledger-based one. It's kind of a strange object capabilities hybrid of both of those. The mint has the authority to produce non-empty purses, basically to create new money. Purses have the authority to produce new empty purses. They also have the authority to produce new full purses as long as there's a conservation of value. You can take a purse, you can $100 purse and split it into two $50 purses. What you can't do is print a $100 purse. That's what the mint does. The way that you handle authority is unforgeable names. We talked about that. So Michael Birch we have some initial work on the Rev Mint contract. The other thing is we will encourage people when they create non-rev assets to use this, because this is the kind of thing that will allow you to scale exchanges in any of the namespaces and do them quickly. So we'll encourage people, when they create their own assets, we'll be setting the example of this is the way to do it so that it will scale. So Mike Stay talked about purses versus wallets. You can take a purse and you can wrap it with a signature verification, but you could wrap it with other things as well, like multiple signature verification, right? Like the same underlying purse code just needs a slightly different wrapper. Now you have a multi-sig wallet. But you can also take the purse and have the purse owned by a lottery contract or an atomic exchange contract. So purses can be wrapped up by multiple things, and they're a really useful building block in how to do exchanges in RChain. All right, so we're going to send Bob 10 rev, and I'm not quite sure that this is. I'm not quite sure what he's doing here, but so the first thing is that address is public, and like Mike said, it would live on the bottom namespace and never do anything. So instead, what it would be is you would send that to the registry, get back a result, and then do this. Do that same send on the resulting channel after looking it up. And there's a subtle reason why we want it to be that, and during the question portion, I'd be glad to explain that. So basically, we do a signature check, and then if the signature matches, we do what's on the next slide. So this would be inside of that block. So basically, we create a new empty purse, we deposit 10 rev in that purse, and we give the entire thing over to Bob. And then presumably he's going to immediately empty it. So I guess you could write code that did nefarious things, that took that purse, gave it to Bob and Fred and George. But the nice thing about rolling is that only one of them is going to be able to succeed at emptying that purse. And then they'll have evidence that you're a big fat cheat. And they won't deal with you anymore. It's not, none of the validators have done anything wrong. But the validators are the ones that catch you to prove that you've done something wrong. So you can attempt to double spend, but you'll get caught. So the registry contract allows you to take and do a lookup from public names to private names. It's just one giant map. And there are rules for creating entries in the map. Like Mike said, IANA, pub key, and hash, and we might consider others, but we will at least have those. So unregulated public names would be user owner friendly, and that's why at the moment they go to the circular file. We won't prohibit it. It actually could be useful we will record and then discard rights to public names. So you could write to a debug channel and then watch the blockchain, and we will record the fact that you sent to the debug channel. We just won't do anything with it. This would be one way that you could have local code interacting with the blockchain is you will see the rights. When you see that a right to a public name has consensus, you can pull that out. But the thing is anybody can write to a public name. So it's not quite unlocking. Instead, it's a lookup. So if you try and do what was here, that right will succeed, but it won't go anywhere. It'll go to the circular file. So we have hashes, public keys, and IANA. Although I don't know that we'll use URLs. but instead they'll just be the domain name because of DNS records. So this was actually an interesting example. The first example, if you were to deploy that, it constructs a contract listening at an unforgeable name. When we get the garbage collector done correctly, we will see that no one can ever write to that name, and we'll just throw it away because it's equivalent to nil, or it's behaviorally equivalent to nil, because nothing can ever make it do anything. The registry example isn't quite right. I had a harder time with this example. I'm sorry, Michael. He's blunt. So basically, when you deploy it, you could just, we will have the ability to say, register and it'll be straightforward to deploy a contract, and we'll actually have tooling to make it easy to say, well, just take this contract and deploy it and give me back the hash so I can publish it on my website. I don't know that all of that will be straightforward and well documented so that everybody gets it right. And ideally, the software will just have that as a default. Deploy this contract and register its hash. All right, so the proof of stake contract, it's another blessed contract. It handles bonding, unbonding, slashing, and rewards. So there's more details. One of the important things to note is that there is necessarily a delay between unbonding, or when you stop being a validator, and when you get your money back. The reason is that that is the amount of that time is the amount of synchrony needed for the network. And we can talk about that at the breakout session. But if you immediately get your money back, you have the opportunity to start lying, and they can no longer slash you. So you can produce alternate histories. So the proof of stake contract sets all of these things. It handles bonding, unbonding, and staking, and bonding and unbonding, and the delay, and slashing. So we'll use the same purse contracts for bonding. So what will happen is while your stake is bonded, it will be held in a purse that you don't have access to. And then after you do that, you get added to the validator list. Like I said, the other part of what it means to be a blessed contract is the Scala part of proof of stake will inspect this validator list. So that's part of what it means to be blessed, is you'll go in and you'll look at this particular list. You call to unbond, you call the unbonding contract with signature return channel. So after that, you become an inactive validator, but you can still be slashed until you get your stake back. Slashing is interesting because a portion of that that verification will be done not in Rolang, but the actual signature and purse distribution, whatever we decide on, will be in the blockchain. So the validator will be required to have cryptographic evidence of the offense. Any validator can slash any other validator. That's one of the things that that you need to know, even if you're not in the same regions. So equivocation, creating an invalid block, failing to meet the performance requirements. The performance requirements will likely not be burn it to the ground slashing, but like equivocation just will be. Yeah, and once you're past the unbonding waiting period, you can hand the proof of stake contract a wallet, or you can use your wallet to hand them a purse, and they'll transfer the funds back out. So the blocks, like I said, the state is the set of Rolang terms. So what's in a block are the post state, what code was deployed, during that block, and the reductions required to get from the previous state to this state. The header will include a pointer to the previous block that has that root hash. We're going to use something like a Patricia try to handle the state. And so as part of that, we have deterministic serialization of rolling terms. When Michael gets here, he can give this part of the talk. So I'm going to wrap it up here. If you have any questions for me, I think I said I'd cover something in the questions part, but I don't remember what it was. So this is your time to repeat it back to me and tell me what I need to tell you. But thank you.
So that was distribution of funds in RSS sending time to the action.
Raise your hand if you want to talk about it.
I just had a question with respect to the block structure. You say that you include the post state, the new code, and the receipts of all of the synchronizations. Why do you need the post state? Aren't you going to be able to find that just by looking at the parent hash and getting it?
Technically, you could, but it's good to have if there is a check that yes, I got to the same place.
That's fine.
It won't be the entire state because the entire state is going to be very large. It's just the delta of the state.
No, we'll have the root hash of the post state.
Oh, okay.
In state-based chains, this is actually a very common thing. You have the transactions of what occurred and the new post hash. So, for example, if you wanted to come up to speed, right, and you knew you knew which block you wanted to come up to speed from, if the post state is in there, you don't have to go back to the beginning of time and follow all the transactions. Somebody can just start giving you the pieces of the Merkle trie, and you can use the trie structure to know that what they're giving you is the right stuff.
The thing you were going to go back to is how mints work and can be distributed among namespaces so they scale.
Oh yeah, I'll come over here. Oh. Oh yeah, I'm just going to do kind of.
Mike Birch says the post hash is for giving short proofs that you have the right state.
All right, so here's a purse. Just write a money bag instead. So the mint lives in A. But so the way that you create an empty purse is you ask the mint for an empty purse, and it will gladly give you one. You don't need you don't need to be the mint owner to get an empty purse. So the purse comes empty. It has some methods, but the important characteristic of a purse is that it can tell. I can construct a different mint. So the most important logic of a purse is the ability to tell that this is not that. It solves the alchemy problem. So we can call this is mint gold, and this is mint lead. Right? We can't turn lead into gold. So, but no matter where the mint lives, you can create a new purse. You can say, create me a new purse. You can give it the name where the purse will live. And it can construct derived names so that everything lives in the correct spot. And then, so even if this is an A, so this region A, right? The purse can live in region B. And then you can create another purse in region C. And then it's straightforward. You can set up an exchange protocol so that you can hands, so you have, all right. So if you wanted to do an exchange, what you would do is you'd spawn a new purse. So, all right, if this has 100 in it, and I'm going to send 10 to C, what I would do, I would split into two, right? D with 90, and then B join C with 10. I have new purse splitting at the joined namespace. Right, and then to receive, C would do the same thing, right? C has X dollars, and then there's, C would create a new purse. Yeah. Although this step might not even be necessary. With 0, right? Like, and then they would get merged, and then you would do code. You would take this resulting purse, and you would do code motion to move it back down, and then join it. So, like, the nice thing is, like, you know, that you don't have. There's a way using bundle. Bundle makes it possible to include with each to give each purse a little bit of code that can tell that it's not lead, and that code can run anywhere. And so you never have to go back to the mint. There's no central authority required to verify that an exchange occurred. Now, the central authority might want to watch all of the places that are doing these things to make sure that.
Set that up as a contract.
Yeah, but the thing is that it doesn't even need to be a contract, right? Because you can any validator can slash any other validator, right? Like, as long as they're behaving, they can't break. You would have to have broken the rules in order to cheat, and then there's cryptographic proof that you've broken the rules. Thank you. So, yeah. So actually, I don't think this is necessary. We just use code motion to migrate down to C, and then we have all right, and so 10 plus X. So that's a basic block diagram of how you could do exchanges across regions with wallets, and then you never have to go back to the central authority, and this makes it so it can scale.
So you said that if the validator violates the contract, it gets slashed, and there's a cryptographic proof that he did that. So I can't imagine, like, what are the examples that the validator violated the contract at. I can't imagine how the cryptographic proof could look like.
By cheating, you have supplied the cryptographic proof because you sign all your blocks. So if you sign blocks that break the rules, you have just supplied cryptographic proof that you cheated.
Yeah, I understand that part. So if I supply the block that with the transaction that break the contract, so they break the rule of the protocol or the language, or like I imagine that I can't create the block that doesn't pass some the contract rules, like.
in order for a coalition to cooperate and give themselves lots of money, they would have to violate the language rules. So there's no way to have 10 evolve to 100 in the reduction rules of the language. So if they swap out 10 that they had for 100, then they have violated that and they can be slashed for it.
I remember one of the other things I was going to cover, which was why we decided that you don't send and receive on the row colon names. You just hand them to the registry, and then you either get back a response. And the reason is, I'm going to do this one over here. We'll leave my example up for now. So we'll show you the two different ways. And so if I just allow versus
That's his
row colon IANA colon pyrefx.net.
okay. Oh, I put that com, but yeah.
That's a fireworks company.
So so
write this a little bit more.
okay. Oh, yeah, it's yeah. All right. Assuming I have some return channel already allocated, and then pipe 4. Yeah. Then, so the difference between these two is the meaning of this doesn't change whether or not this is registered. We'll have some ability to get a return or an error code if it's not registered. And so what that means is if it's not registered, the error code fires. If it is registered, this fires.
Put that in a match or a select.
Well, yeah, we can put it in a select once we get that working, or just make them mutually disjoint, like what will be returned. Yeah. We have to garbage collect anyway.
I'll shut up.
So, but the meaning of this doesn't change whether or not this is registered, whereas the meaning of this changes whether or not this is registered. And what we didn't want was for the meaning of code to change based on what is on the blockchain. So this always means the same thing. It means try and get it the name lookup, and if it's there, send on it. And if it's not, don't.
And it also gives us a place to stand to get a different name when the domain changes hands.
Yes. Yeah, so if the domain changes hands, you can register a different name there, and then anything that still has the name anything that's still running that has a handle on the old name will continue to run, but anything that's deployed after that point, when it looks it up, will get a new name. This is also a way, this is one reason why we might want UUIDs and not just hashes, is because that will allow you to update your code. And, I fixed the bug. Well, the hash changes, as it should, but it would be nice to be able to deploy to just a random UUID, and then when you fix a bug, you can...
Yeah, so it allows us to make two different kinds of guarantee. One is this code will never change, and the other is this code will always be updated to the most secure version.
Yeah.
Mutability, here we go.
No, it's not mutability. It's the fact that what you get back depends on the state. But that's true of like all kinds of other contracts, right? Like, if I ask you for your wallet balance, like I'm going to get a different answer based on what I ask. Unless you never spend anything. Right? Like, I guess if I ask Satoshi's balance, it always stays the same.
Until it doesn't.
Yeah, well, when it doesn't, the whole world will hear about it. So that was, I remember talking about, saying I would answer that during question and answer. Are there other questions about what the state is?
So I have another question about the Mint contract. So the blessed rev is a contract running in every namespace. Is there one Mint contract for rev, or does each namespace have a rev Mint? Or what does that look like?
It could have a rev Mint in every namespace. The reason to do that is not one of security, but rather one of performance, that you don't have to send a message across to another namespace and wait for the finalization sort of stuff to happen before you get your purse back. So this one can run. It's got the secret that's identifying it as gold rather than lead. Each one of those is done in that particular namespace.
Yeah, when in order to have funds that only you control, you have to get a wallet directly or a purse directly from the Mint. You can't just, somebody gives you a purse with $10. The thing is they still have a handle on it. So what you want to do is empty that immediately. And you need somewhere to empty it to. It would be very possible to attenuate the Mint and produce copies running in various regions that have the ability solely to produce empty purses. So you might deploy like the full power Mint one place and an attenuated Mint in several places.
One thing that was on the slides here, to prevent hostile takeovers of namespaces, Birch proposed that there would be a limited number of validators per namespace, but we may use some other policies like having to pay every existing validator a fee, as well as the bond, so that fees for attempting to overwhelm an existing namespace would be quadratic in the number of new validators, or we could make it depend on the number of validators, so it's cubic or exponential or whatever we want there. But that's one of the things that we haven't decided on yet, exactly how we're going to try to prevent takeovers of namespaces. Also, the Mint, if it has to exist in each region, would need to be magicked up as code gets deployed to a region, because we don't want 2 to the 256 copies of Mint code running.
Can I ask a question about registry? Is this on? Okay, so then will the registries be housed on a validator node within a namespace within a region? Is the registry going to be at a hierarchical level that's above all regions? I know last talk we were talking about all of Rho. Is that where the registry lives, up at that level, or are there going to be registries that are kind of more focused or more regional?
I don't have a good answer for your question, sorry. So,
raise your hand if you understood the majority of what Kyle's presented.
On the whiteboards or on the slide?
Yes.
Well, we can do it separately. Raise your hand if you understood what I presented on the slides. And
Casper?
Well, I didn't understand Casper, so right.
Nobody understands Casper.
So
I mean, this is a.
We'll let Michael present it when he gets here.
I didn't ask that question because Mike's not here, right? Kyle's stepping in. So you're doing it.
Kyle's kind of doing a heroic job, just stepping in on a presentation cold, and so it's going to be hard for us, you know. And so what I would ask is that when Mike gets here, go nail him to the floor until you understand, right, what the content of the presentation.
Check. Some of the Mint stuff is actually, at least to my mind, easier to understand going through the code line by line. It's not that much code. 66 lines, he says. And I'm actually tuning one of my presentations. I might do a little bit of that. So.
Yeah, mints are actually straightforward to understand. They're not what any other blockchain has done, and so they're simple. They're not easy. That's actually the title of my talk. On rolling is simple, not easy. Because no. There's this talk about that somebody else gave about simple and easy. Yeah, if you haven't seen it, it's definitely worth an hour of your time. He talks about easy means familiar, and simple means not a lot of moving parts. So rolling is very unfamiliar, but it's simple. So the mint model is mints and purses are simple, but they're not easy because they aren't what any of the other blockchains do.
That's not to say that we couldn't do that. It's just that this scales better.
Yes.
By a lot.
It scales in two ways. Number one, you can spread purses over all of the regions. And number two, it makes it so that, if even within a particular region, if two purses are not, if two transactions don't interact, you can run them on separate processors. There's not a need to have an ordering because they commute. So who cares what order they ran in?
I thought you were going to say something else about scaling, which is it also scales conceptually, right? You can wrap purses in lots of different kinds of contracts, right? So it scales in terms of reusability.
If there aren't any more questions, I think, where are we on time?
Yeah, if there's no more questions, we should wrap it.
Yeah, let's wrap it up.
Questions?